proceed on to sample problem 2. What mass of silver oxide, silver 1 oxide, is required to form 388 milliliters of O2 gas when measured at 734 millimeters of mercury and 25 degrees Celsius? Okay, so mass is what we want to get. We're given volume, we're given pressure, and we're given temperature. And you guess what? You have a chemical equation here, which pretty much means you have a stoichiometry problem. So always the first step is to balance. So when we go ahead and balance this, we're going to need 2 silver oxides and 4 silvers. Okay, so we want to go from basically the following. We're given the pressure, the temperature, and the volume of O2. Well, that's 3 out of 4 parameters, and so we can go ahead and get the moles of O2. So NO2 is equal to PV over RT, and so that's going to be equal to 734 millimeters of mercury times 1 atm divided by 760 millimeters of mercury. Going to multiply that by the volume in liters, which is 0.388 liters, divided by the universal gas constant, 0.08206 liters atmosphere kmol, times the temperature in Kelvin, 25 plus 273.15. So then the moles of O2, we get 0.015 moles of oxygen gas. All right. So we want to go from moles of O2, which is what we have, and somehow we want to go all the way to the mass of silver 2 oxide. Well, we know how to do that. This is really now just a matter of doing something we've already learned. So we're going to go from the moles of O2 to the moles of silver 1 oxide using the mole to mole ratio, and then on from there is to the mass of silver 1 oxide using the molar mass. Okay, let's go ahead and finish this up. So you have 0.015 moles of O2. Okay, the mole to mole ratio is going to be 2 moles of silver 1 oxide for every 1 mole of oxygen gas. And then we're going to go ahead and multiply this by the molar mass of silver 1 oxide to get to grams. So its molar mass is 1.74 grams for every 1 mole of silver 1 oxide. And so we get roughly 7.0 grams, everybody, of silver 1 oxide that are required. Okay, so that is another stoichiometry problem that involves gases, everyone. Thank you all for your attention, and I'll see you all next time on Educator.com.